Hi, welcome to ChemTube channel. I'm Jagu Wong. In this video, we do some question in Paper 2 Structure and Essay. Do subscribe our channel, like and share this video with friends. Okay, now let's look at section C, Essay question. Table 4 shows the observation when 3 oxides of elements in the period 3 are added to potassium hydroxide solution and nitric acid. So let's see, there are 3 oxides given here, P, Q and R. So when added to potassium oxide solution, which is alkaline, if it has a reaction, meaning that it is acidic properties. For example, like if the solid oxide soluble, meaning that it has acidic properties. Insoluble means no reaction. Okay, meaning that these two got reaction, meaning that they have the acidic properties. Then if react with the nitric acid, okay, if reaction occur, meaning that it has the alkaline properties. For example here, okay, these two got reaction, so alkaline properties. Okay, but if we look into this P, okay, it has acidic and alkaline properties at the same time, meaning that we have a special name for it that is called amphoteric oxide, amphoteric property. Okay. Then for Q, it reacts with the acid, meaning that it has alkaline properties. And then R, it is soluble in the potassium hydroxide, meaning that it is acidic properties. Okay, so here we know the properties of the oxide of PQR already. Okay, so now based on the table, arrange PQR in the order of decreasing atomic size. Okay, then state the oxide of P, Q and R. Then write the chemical equation for the reaction between the oxide of Q and the nitric acid. So 6 marks. Okay, so suggested answer, we know that the atomic size decrease from left to right in the same period. So we know that, okay, the answer should be Q, P and R. Okay, so suggested there, okay, P is aluminium oxide because it is the amphoteric property. Okay, then next one, Q is the alkaline, right? So we make a suggestion, so Q can be magnesium oxide. Okay, then R is the acidic properties, right? So R we suggested is sulfur dioxide, for example. Okay, so let's see the chemical equation for the Q, magnesium oxide, for example. So here we still use the Q lah. But in actual fact, you can use the magnesium oxide to replace the to be written in the equation. So let's say we still use a Q. Okay, magnesium oxide react with nitric acid. So you produce a Q nitrate and water. So we need to balance the chemical equation. Okay, so this one times 2. Okay, So in actual fact, you also can use the magnesium to replace the Q. So for example, you can write magnesium oxide react with nitric acid. So you produce the magnesium nitrate and water. Also correct, so you need to balance the chemical equation. The nitric acid need to times 2. Okay, B. Bromine gas reacts with hot iron ore to form the brown solid. So brown solid here actually is iron 3 bromide. So write a balanced chemical equation. So balanced chemical equation. Then calculate the mass of the brown solid form when 0.1 mole of bromine gas reacted completely. So we need the relative atomic mass for iron is 56 and then bromine is 80. So 4 marks. Okay, suggested answer. First, we need to write the balanced chemical equation. So the bromine react with the iron, hot iron. So you will produce the iron 3 bromide. Okay, so we need to balance the chemical equation. Here 3, here 2. So we need to times 2. So we get 6 bromide. So this one times 3. Then iron times 2. Okay, so this is a balanced chemical equation. So given to you, the mole for the bromine used is 0.1 mole. So the mass for the product you need to find out. Okay, so first one, we know the mole already for the bromine. Okay, so no need to calculate anymore. So first we can directly go to the mole ratio. Okay, so mole ratio we need to compare from the equation. So 3 moles of bromine, okay, you produce 2 moles of iron 3 bromide. Okay, so this is from equation. So meaning that if here 0.1 mole of bromine, so what is the value or what is the mole of the iron 3 bromide, we need to find out. Okay, so we can use the cross multiplier. So you will get this one, it will be 0.067 mole of iron 3 bromide. Okay, so meaning that now the mole is 0.067 mole. Okay, after we have the mole, we can get the mass of iron 3 bromide producer. Okay, so mole we have already 0.067 times the molar mass of the iron 3 bromide. So we total up. So iron is 56. So bromide is 80. There are 3 of it. Okay, so use our calculator. You'll get the value is 19.83 gram. Okay, unit must be stated correctly. Okay, C. Diagram shows a flow chart showing the different types of reaction involve the elements from the periodic table of elements. Okay, so X W, okay, react with the chlorine, it forms the sodium chloride. So meaning that W contains the sodium. Okay, with water, it produces sodium hydroxide and hydrogen gas. Okay, so confirm, we know that this W is Na, sodium. Okay, so when you react with the oxygen, so it produces the sodium oxide now. Okay, then when sodium oxide react with the water, then when you will produce the sodium hydroxide. So roughly we know what is the trend already. Okay, now What is the question? State the color change when a few drops of phenolphthalein is indicator is added to the solution form. So in the reaction 1 and reaction 4. So give a reason. Okay, next question. Briefly describe how the reaction 3. So reaction 3 is the reaction between the metal with the chlorine. Okay, so reaction 3 can be carried out in the school laboratory. So in your description, you have to include the procedure, observation, and then the chemical equation. So 8 marks. Okay. So when the phenolphthalein is added to the alkaline solution, okay, so colorless solution turns pink. Okay, yeah. Why? Because hydroxide ions is present in the solution. Okay, then next question is about the reaction between the alkaline metal with the halogens, chlorine. Okay, so we need to start from the procedure. So first we need to cut the alkaline metal, right? Okay, cut. Okay, we cannot use the very big size of the alkaline metals because they are very reactive. So next one, we need to clean the sodium metal with filter paper. Okay, because the alkaline metals need to be put in the paraffin oil, so you need to clean first. Okay, step 3. Okay, place the sodium on the scoop of the deflagrating spoon using forceps. Okay, next we need to heat the sodium until it starts to burn. Okay, after that we need to lower the spoon, okay, quickly into the gas jar. Filled with chlorine gas. Okay, then after that we need to record the observation. Okay, so these are the steps that we need to take for doing this experiment. So what is the observation? So we can observe okay, the sodium, okay, it burns with Okay, bright yellow flame. Okay, then you will produce white solid. Okay, so in actual fact, what is the chemical reaction? So chemical reaction equation. So the sodium react with the chlorine. So it forms what? It forms a sodium chloride. So we need to balance the chemical equation. This one times 2, this one times 2. So during this reaction, because of chlorine gas is very poisonous, so we have to conduct this experiment in the fume chamber.